Okay, everybody, today we're going to continue working on lesson 2, but this time we're not dealing with multiplication in exponential form. Today we are going to work on division of numbers in exponential form. So you might want to label that in your notebook that we're working on division of numbers in exponential form. The learning outcome. Students see a rule for simplifying exponential expressions involving division. So you're going to learn or memorize the rule whenever you are using exponential expressions involving division. And just a little bit of a review for multiplication. Remember, you look for any similar bases. So here I had a base of 10, a base of 10, so I'm going to rewrite that base of 10. And remember, I do not multiply my exponents, instead I add them. So I would be doing 10, and then my exponents, I'd be doing 2 plus 5. And then I have a value of 3 as a base. And my exponents in this case are 3, and remember, if you do not see a value, it's considered to be 1. So then we would just simplify. So this would become 10 to the 7th power times 3 to the 4th power. The next one. So the next thing I would do for number 2, or actually the first thing I would do for number 2, is first multiply your values out front. So I would multiply 3 times 2, which gives me 6. X is my base. And then I'm going to add my exponents. So 2 plus 5, because those are my exponents, would give me 7. So this answer would become 6x to the 7th power. Remember, here's my answer up here just to separate a little bit. So remember, like I said, the rule, anytime you have the same base, all you have to do when you're multiplying is literally add your exponents. Please remember this. This is also on your handy-dandy formula sheet. So the goal today is to figure out what the rule would be for x to the m power divided by x to the n power. Here you see we have similar bases. My base is x. So what would I do with my exponents? That is honestly what we are going to figure out and work on today. So let's take a look at this. If I have 3 to the 7th divided by 3 to the 5th, I could literally write this out. So in my numerator, I could be rewriting 3 7 different times. Let's count to make sure I have 7. 1, 2, 3, 4, 5, 6, 7. In my denominator, I'd be rewriting 3 5 times. Once you have that, you could cross off what you have in common. So here I have 1 in my numerator, 1 in denominator, again, 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 and 1 more time. So all I'm left with is my base of 3. And how many times does that repeat? Well, in this case, it repeats 2 times. So 3 to the 2nd power would be my final answer. Some of you might start to see the relationship between writing it in this form to this form, so you did not have to do all of this work up here, and that's actually what we are going to get into in a moment. Let's take a look at this again. So if I have 3 to the 5th to the 8th power, remember, anytime you have a fraction, you want to keep it in parentheses. So I'm going to be having 3 to the 5th, and in my numerator, I need to rewrite this 8 different times. Hopefully, I do not run out of room. Just enough space So I have 3 to the 5th 8 different times in my numerator. In my denominator, I would be rewriting it 6 times. Okay, so once again, like I did on the previous example, I can cross off if I have the same thing in my numerator and denominator, because that would just reduce or divide to 1. So those cancel, cancel, can cancel anytime I have it in common. I'm left with these two lonely soldiers in the numerator. So in this case, my base is 3/5, and how many times I have left would be 1, 2. So 3/5 to the 2nd power is my next answer. And lastly, let's look at one more example. 4/5 over 4 squared. Well, I could do what I've been doing, rewriting it how many times I have my exponent. So I'm rewriting the 4 5 times in my numerator, only 2 times in the denominator. I can cancel out 1, 2. I'm left with 4 times 4 times 4, which would also be 4 to the 3rd power. So I hope you're seeing the rule that anytime you have division, instead of adding your exponents, what's the opposite of adding? The opposite of adding is subtracting. So in this case, if I write down my base and subtract my exponents, I would get 4 to the 3rd, which also matches if I did it this longer way. So let me go back here. Once again, for this example, how I got 3/5 to the 2nd power, instead of doing all of this work, I could literally write my base. Anytime you see division, you are going to subtract your exponents. And does an 8 minus 6 give you 2? That's why this was my final answer. So the next page in your packet, let me fast forward to that, please. You would have something that looks like this. Actually, no, I lied. It's right here at the bottom. So here's the rule I just discussed with you. Anytime you have the same base, which we do here, it's x, all you have to do is subtract your exponents. These next few examples are in your notes packet that we passed out to you. So why don't you try to do exercises 21 through 24, pause the video, and when you're ready to check your answers, you may press play. Alright, let's start to check our answers. So for exercise 21, my base would be 7, and if I subtract 9 minus 6, I get 3. 8/5 is my base. Make sure since it's a fraction, you put it in parentheses. And if I subtract my exponents, I get 7. Exercise 22, once again, my base has to be in parentheses because I'm dealing with a negative base. And if I subtract my exponents, I get to the 9th power. And 13 is my base. If I subtract 5 minus 4, I get 1. Technically, though, you don't really see the 1 ever, so this would be your final answer. Remember, as always, ask questions or pause your video and ask your teacher for help if needed. Moving right along, though, to exercise 25, it says let A and B be non-zero numbers. What is the following number? So do not let this get you confused or worried. Anytime we have variables instead of numbers, you are still doing the same thing. So the first thing I'm going to do is rewrite my base. Since it's a fraction, A over B, I put it in parentheses. And since I'm dealing with division, I'm just subtracting my exponents. So my final answer would be A over B to the 7th power. you do the same thing as you did with numbers, like we did on the previous page, whenever you have variables, same thing. So why don't you try to do exercise 26? You can pause the video, and when you're ready to check your answer, press play. So your answer for exercise 26 would be x, that's my base, 5 minus 4, which in this case would be x to the first power, or just x. Alright, moving along, it says, can the following expressions be rewritten in simpler forms? If yes, write an equivalent expression. If not, explain why. Well, Mr. Kate talked to you a little bit about this yesterday when it dealt with multiplication. So you are going to follow the same rules, except this time we are going to see if they would divide. So here we have 2 to the 7th over 4 squared. And then they rewrote it as 2 to the 7th over 2 to the 4th. Well, 4 squared is 16. So if you're confused how they got from 4 to the 2nd to 2 to the 4th, I need my base to be 2. So I have to think 2 to what power gives me 16. In this case, 2 to the 4th gives me 16. So now that I have the same base of 2 right here, I would then just subtract 7 minus 4, which in this case would be 2 to the 3rd power. We needed to rewrite it with the same base because this right here would not work because we did not have similar bases. Therefore, we would not be able to follow the rules for division with exponents. If you look at exercise 28, we want our base to be 3. So that's how they changed 27 to 3 to the 3rd power, because 3 times 3 times 3 does give you 27. Now we have, from here we have the same base. So my base is 3, and I can subtract 23 minus 3, which in this case would be 3 to the 20th power. Exercise 29. Following the same suit, 3 is one of my bases, then I can subtract those exponents, 5 minus 2. But then I also have 2 as a base, and I'm going to subtract 8 minus 3. So my final answer for exercise 29 would be 3 to the 3rd times 2 to the 5th. All I did was only subtract exponents that had the same base. Why don't you give exercise 30 a shot, and then whenever you're ready, press play and check your answers. So for exercise 30, you should have -2 as one of your bases in parentheses because it's a negative base to the 2nd power, because 7 minus 5 is 2, times 95, and 5 minus 4 is 1. So you could technically have to the 1st power, or -2 to the 2nd power times 95. Both of those answers would work. Okay, let's try a few more. So for exercise 31, all you are going to do is basically think of this value, this, and this as the numerator of your fraction. So all you have to do is multiply 5 into that, because both of those are technically in your numerator. You could think of the 3x to the 8th power over 1 if you really wanted to. So in order to get my answer, 5 times 3 is 15. I'm left with 15x to the 8th in my numerator. Like I said, all I literally did was multiply your 5 and your 3. And then in my denominator, I have x to the 3rd power. Now, since I have a same base, I can simplify. So 15 is my coefficient, x is my base, And 8 minus 3 gives you 5. So that is my final answer, 15x to the 5th power. Why don't you give question B and C a shot, and then when you're ready, press play to check your answers. Okay, so for question B, your final answer would be negative 20x to the 3rd, because all I did was multiply the 5 and my negative 4, and then I just subtracted my exponents. For question C, you should have 55 from 5 times 11, and then my exponents, 4 minus 3, would give you 1 with the base of x. Do not worry about question 32. So if you move on to your next page, what I want you to do is try to do number 3, this set right here on your own right now. Try to do this, and when you're ready to press play to check your answers. Alright, so as you can see here, the answers in green all dealt with multiplication. So I had to add my exponents that had similar bases. So I got negative 19 to the 16th, 2.7 to the 8th, 1/5 to the 17th. Down here, this is where sometimes students get confused. Negative 9/7 is my base. My exponents are m and n, so since they're not actual numbers, they're just variables, I'm just literally going to write that down, m plus n. The division problems are in dark blue, so 7 was my base, and 10 minus 3 gave you 7. Over here, I only had that a in my numerator, so I rewrote it. B was another base, and 3 minus 2 gave you 1, or just AB. As always, if you're not understanding that, please ask your teacher for help. And we are just going to look at 2 more examples, and then I'm going to let you practice a bit. So for this example, whenever you're given values out in front, the first thing you're going to want to do is either simplify, reduce your fraction, or divide if you can. So 10 divided by 2 would give me 5. So I get 5. X is a base, and if I look at my exponents, I have 5 and 3, so I would have x to the 5 minus 3 power. And y, my exponents are 2 minus 1. Remember, right here, if you don't see that 1, it's assumed to be 1, you can write it in. So then if I would go ahead and simplify, I would have 5 x to the 2nd power y. For that next example, I cannot divide 18 divided by 10 nicely to give me a whole number, but I can reduce it. So if I reduce 18/10, I could divide both of those by 2 to give me 9/5. B is one of my bases. I would do 10 minus 7 because I'm dividing, so I would subtract my exponents, and then I also have a y to the 9th power in my numerator. So if I simplify that a bit more, I have 9/5 b to the 3rd y to the 9th. If you are not understanding how I'm getting any of this, or you still have a question, please ask your teacher. Just a few things to wrap up. Just to summarize, and you're probably going to want to write this in your notebook. The multiplication rule: multiply any coefficients if you have any first. Remember, you always add your exponents with the same base. The division rule: remember, you subtract your exponents with the same base. So right now you can start to do your homework that your teacher will tell you, and as always, if you have a question, please ask. Thank you so much, and have a wonderful day.